All right, so today we're going to be talking about inverse functions. First of all, when we have an inverse relation, that means that the input and the output are interchanged with each other. So what I mean by that is basically x becomes y and y becomes x.
Always?
Yes. We're just switching the places of the x and y. And when we graph them, which we will be doing, not today, but we'll be doing it tomorrow, the graph is a reflection across the line x equals y. Yeah. Okay, so the input and the output are interchanged, and the graph is a reflection across the line x equals y. So for example 1, I'm going to find the inverse of the relation y equals 3x minus 5. So I literally just put an x where the y was, and put a y where the x is. Okay, so now I have x equals 3y minus 5, and I solve for y. I get the y alone. So I need to add 5 to both sides. So x plus 5 would equal 3y. And then I have to divide both sides by 3. And so y would equal 1/3 x plus 5/3. And that is my inverse relation. Any questions? All right, so if we have inverse functions, functions f and g are going to be inverse of each other if f of g of x equals x and g of f of x equals x. So basically, if I put the inverse into the original function, or vice versa, it should simplify down to just being x if they are in fact inverses of each other. And we usually write it as like f to the negative 1 of x, but then you would just say it f inverse is how we say it. Okay? All right, so what we're going to do now is we are going to verify that f of x is equal to 3x minus 5 and f inverse of x is 1/3 x plus 5/3. We're going to verify that they are inverse functions. So what I mean by that is I'm going to look at f of f inverse x, and I'm going to look at f inverse of f of x. So for the first one, I'm going to plug my inverse into the original function. So I'm going to have 3 times 1/3 x plus 5/3 minus 5. So if I distribute my 3, I get x plus 5 minus 5, and so that comes out to equal x. So far so good, right? And now I'm going to do the opposite. I'm going to go the opposite direction and make sure that it works also. So I'm going to plug 3x minus 5 in for x in the inverse of x. So 1/3 times 3x minus 5 plus 5/3. And so if I distribute my 1/3, 1/3 of 3 is just 1, so I get x, and then minus 5/3 plus 5/3, and sure enough, that one works as well. Therefore, the functions are inverse functions. Okay, any question about what I did?
Where'd you get the, I guess, how'd you know which of the functions uses which problem? Like, for instance, you used 5 over 3 and 1 over 3 in the second problem, how'd you know that that was the numbers you were supposed to?
How did I know what I was plugging into what?
Yeah.
It doesn't matter which one you do first as long as you try them both ways. So I don't care if you test one direction first and then test the other direction second. Just so you test it both ways to make sure it works. Harrison, did you have a question? All right, so I'm going to have you guys first just find the inverse and show that to me, which that should take you guys like almost no time. Because what can we write instead of f of x? We could write a y, couldn't we? Yeah. So if you think of this as being y equals x plus 4, find the inverse for me. So did we all get that the f inverse was x minus 4?
Yeah.
Right. That one's pretty straightforward. Okay, so now I want you guys to figure out, verify, show with your work, not just in your head, that that comes out to x and that the inverse of f of x also comes out to x. Okay? So now just verify that when you plug them in either direction, you end up with just x for an answer. Okay, so did you guys, this one was pretty easy, wasn't it?
Yeah.
Yeah, you just get x minus 4 plus 4. They cancel out. The other one's x plus 4 minus 4. All right, let's do one where you have to work a little bit harder. All right, let's find the inverse of this one. All right, so are we coming up with 1/2 x plus 1/2? All right, then let's plug it back in and make sure it works. All right, so when you plug the inverse back into the original function, you get x. When you plug the original function back into the inverse, you also get x. Therefore, you've verified that is the inverse. Any questions? No questions. All right, that's it for today then.